All right, so today's lesson is on vapor pressure, where vapor pressure is defined as the pressure exerted by a vapor at equilibrium with its solid or liquid at room temperature. So, what in the world does that mean? All right, as a substance moves into the gaseous phase, then the gas is a vapor. All right, and we know that pressure of a system comes from a gas. So as there are collisions happening with the gas particles and the container of the wall or the walls of the container in which that gas is held, then we end up with a pressure. Okay, so as we go into the gaseous phase, we get pressure. The more gas, the more pressure. All right, why does vapor pressure increase as temperature increases? Now remember, as temperature increases, particles' kinetic energy increase. So the more kinetic energy there is, the more ability that substance has to become a gas. So the more gas particles that I have, the more vapor pressure, or all right, the more vapor. The more vapor, the more collisions. The more collisions, the greater the vapor pressure. Okay, so as temperature increases, we are increasing kinetic energy. Therefore, more particles are moving into the gaseous phase, more collisions, more vapor pressure. We have two types of vocabulary terms here, volatile and non-volatile. When we talk about a substance being volatile, we say that that means that substance will evaporate easily. It's going to evaporate easily because it's going to have weak intermolecular forces. All right, so remember those intermolecular forces are the forces holding particles together. So the weaker the intermolecular force, the easier it is or to break that force, the less energy required. Therefore, we have an evaporation more easily. Therefore, it will have a low boiling point, and some examples would be methane and rubbing alcohol. A substance that is non-volatile is a substance that will not evaporate easily because it has stronger intermolecular forces. More energy is required to break those intermolecular forces. Therefore, it also has a high boiling point. So with that information, let's look at a vapor pressure curve and let's answer some questions about this. All right, so a vapor pressure curve here is the relationship between the temperature of a substance and its vapor pressure. So we have three substances here, and we have this dotted line you'll see is at 101.3 kilopascals. So this is our standard pressure. All right, so number one, when the atmospheric pressure exerted on the surface of CHCl3 is 101.3 kilopascals, what will be the boiling point? So we're just going to simply come up here to our vapor pressure. We're going to find the substance, which is right here. All right, this line right here. And it asks about 101.3. So here we go. We're going to look at where that is and come down. And we see that it is pretty close to 60 degrees Celsius. So what is the normal boiling point for CCl4? So the normal boiling point would be at standard pressure. So again, I'm going to find CCl4, and I'm just going to simply come down. I'm going to read the graph, and I see it's somewhere around 75 degrees Celsius. What is the pressure when water boils at 70 degrees Celsius? So I can get the temperature of water to boil at a lower temperature by adjusting the pressure. So let's find what pressure I would have to adjust water to. So here's my water line, 70 degrees. I'm going to read over, and I see that I have a vapor pressure or needed of approximately 30 5 kilopascals. Which liquid on the chart has molecules that exert the strongest attractive forces? Okay, so here's where students get tricked up. A strong attractive force means a lot of energy to break. More energy to break means less particles in the gas phase. Less particles in the gas phase, less vapor pressure. So when I look at this, 3 different substances, I see at 101 kilopascal, water has the highest temperature. The most energy is required for water. So that means that water has the strongest attractive forces out of these 3 options. Increasing temperature usually causes vapor pressure to increase. All right, so that's going to be true. Why is that? Because an increase in temperature causes more liquid particles to move into the gas phase, more gas, higher vapor pressure. So let's just write that. Increase in temp causes more liquid particles to move into gas phase, more gas, higher vapor pressure. So more gas, higher vapor pressure. All right, so which of these liquids would be the easiest to evaporate? All right, so if we wanted to make it the easiest to evaporate, that means the least amount of energy needed to break the attractive forces. So I'm going to just come back up here. I'm going to look which one requires the least amount of energy to break an attractive force. So here at my standard pressure, I find that CHCl3 has a temperature of 60. All right, now this would be its boiling point. Remember, evaporation occurs at the surface of a substance. Since temperature is the measure of the average kinetic energy, then some particles are moving with enough kinetic energy to move from a liquid to a gas, even at room temperature. Okay, so keep that in mind. We typically read our vapor pressures and we just kind of look at the standard pressure and we look at its boiling point, but keep in mind that that's technically not evaporation, but it does lead us to the right answer. Usually. All right, it's an okay assumption to make. All right, so CHCl3 we saw is going to be our answer. At what temperature would CCl4 boil? At 40 kilopascals. Okay, so at 40 kilopascals, here I am right here, and I'm just going to come over, and I'm going to come all the way over to my CCl4 line, and then I'm going to come down and read the graph, and it looks to me like it's going to be somewhere around 49 degrees Celsius.